Hello and welcome to the Digital Orphanage. This episode, we continue with part 2 of our Amiga 2000 series. In part 1 we looked around and inside two Amiga 2000 computers from the Museum of Computing in Swindon, and we saw just how much expansion capability they offer over an Amiga 500. In part 2 we start the refurbishment, preparing them for a functioning life in the museum. Unless you live in a parallel steampunk dimension, playing the simulator called the Chaos Engine on your mechanical Babbage B2000, your Amiga will have an electric power supply. It's tasked to provide a low voltage DC supply of electricity from a mains voltage AC source. The power supply unit, shortened to PSU, must provide stable voltages. Too low and the computer might crash. Too high and it can be permanently damaged. Before switching on for the first time any computer as old as these Amigas, it is sensible to test the power supply in isolation. On the Amiga 500 that's an easy task as the PSU is external, connected via a socket on the rear of the case. The Amiga 2000 however has an internal PSU connected directly to the motherboard, requiring the computer to be opened up first. Once the top part of the Amiga's case is removed, you can disconnect the PSU from all internal components and test in situ. However, a major component of any power supply is our friend the capacitor, which helps to smooth out ripple voltage. Over time, electrolytic capacitors are likely to fail for a variety of reasons, no longer providing the capacitance required. As I want these Amigas powered on all day, I'm going to take preventative action and replace all the capacitors. For this reason, I've removed the PSU completely, so we can work on it on the bench.
The Amiga 2000 uses a switching mode power supply, and without a load, the voltage fluctuates wildly. As a test load, I will use a low voltage light bulb on the 5V supply. The voltage is now stable, although probably within tolerance. I still want to replace the old capacitors. After switching off and waiting a few minutes for the capacitors to discharge, I unplugged the PSU. The case is secured with 6 screws. Mains voltage electricity can be fatal. Obey these warning messages, and don't follow my lead. The high voltage on one side of the circuit board is kept separate from the low voltage side. The board is secured with only 3 screws. The screwdriver I'm using has insulation to protect me from any residual charge in the circuit. One corner has a ground clip I need to return to the same place later. A grommet stops the wires being cut and shorted on the sharp case edges. I need to take care not to short out the capacitors on the case when I remove it, particularly the large ones. The fan and mains wires tether the board to the case. As the fan is riveted, it is easier to unsolder the wires. But first, using a wire and resistor, I must ensure all the capacitors are discharged. No sparks here, and a check with a multimeter shows no voltages across the capacitor pins. Safe to proceed, I unsolder the thin fan wires first. This task is made easier since I've finally invested in a desoldering device. wrapped around the wire bundle for basic strain relief, no doubt. I like to take notes as I remove components. Unfortunately, I have learned the hard way of its worth. The mains, live and neutral wires are the last tethers to the case. Vibrations in switching mode power supplies can cause solder joints to fail, so this adhesive adds mechanical strain relief. Because of the adhesive, I need to support the board well to not break it while removing the capacitors. I make a simple plan of the board as I go, noting capacitor values. I first try a nylon spudger to remove the old adhesive without scratching the board, but it fails. So I resort to careful use of a blunt, flat blade screwdriver. Some IPA ensures clean surfaces for new adhesive and solder. Good quality capacitors from reputable suppliers are worth the additional expense. Technology advancements may have shrunk the height of some, but the values, diameter and lead pitch are the same. The large capacitors have snap-in leads that hold it in place and don't need trimming. My homemade solder fume extractor still works great. Why not watch my video on how it was made? The smaller capacitors need their leads trimming, and I have learned from others it is better to do this before soldering. First I trim one lead only per capacitor, the lead left long, holding the capacitor in position for soldering. Then the other lead is trimmed. And soldered. While I have easy access, I brush away the years of dust. My father taught me the importance of quality control, so I inspect my work for defects. When replacing the adhesive, it is important to use the correct type. This is the electronics grade and does not contain chemicals that will corrode your components. It may look like bathroom sealant, but the lack of a vinegar smell tells me it's different. And I leave it to cure until the following evening. I use a sacrificial CD-ROM drive to check it works properly. and measured the voltage under varying load. I'm pretty sure the almost 2V drop on the 12V line is normal, as the PSU reacts to the sudden demand. With the case lid off, we can clearly see the heat profile of the PSU. Most of the heat is created by the high voltage side, from components like power resistors. However, with the lid removed, the cooling airflow is not present, so I replace it. As well as positive 5 and 12V, the Amiga 2000's power supply also provides negative 12 and 5V. And I am pleased with how close the values are. It also supplies a 50 or 60Hz signal from the main supply for the motherboard's use. With a final check to ensure nothing is overheating, I screw the lid in place. I'll leave it for a little to soak test before doing it all again for the other Amiga power supply. In the next Amiga 2000 episode, we'll be examining the most important component, the motherboard. So like, subscribe, and tell your Amiga friends. Until then, good night, and remember, don't let the computer bugs bite.
Let me see your identification. We don't need to see his identification. Follow me. Move on.